Good evening, everyone. Myself Gautam Sarma. I welcome you all in Sapiens Education. So today I'm going to discuss about the torque, which is the part 4 video of this. So before that, shall discuss about the current loop as a magnetic dipole. So we have already discussed about the dipole, right? So let us consider there is a current carrying conductor, okay, and it is in the form of loop. So this is in the form of loop. So the magnetic field will be in this direction. Why? Because if you use the right hand thumb rule, so you will get that the if curl is in a current, so magnetic field will be given by thumb. Okay. So this is the current loop as a magnetic dipole. See here, this is an upper face which will act as a north pole and lower face which will act as a south pole. Why? Because as it is in this direction, so what will happen? The magnetic field is in this direction. Okay, so this magnetic dipole moment of the current loop m is directly proportional to the current. So if you want to find a magnetic dipole moment, so what happens? Magnetic m is directly proportional to the current. If you increase the current, so what will happen? You will get increase in the magnetic dipole, right? Dipole, see, current carrying conductor can behave as a magnet. So that's why we want to find a dipole. So dipole will be in the direction from south to north. Magnetic dipole moment we are talking about. So if you want to find a dipole moment, so see here, as basic rules is that if current, you increase the current in the loop, so it will also, that means magnetic dipole moment M is directly proportional to the current carrying. Now, if you increase the area, let us suppose this is a circular section, so it has some area. If you increase the area, so what will happen? If you increase the area, so magnetic dipole moment will also get increased, right? So this will get also increased. So I hope you have understood this, right? So since if you combine this, so what you are getting M is proportional to IA, and if you remove this proportionality constant, so what we will get? K as a constant. Here K is equal to 1 as per the experiment. K is 1. So finally, magnetic dipole moment is equal to Ia. So if there is a current carrying loop and it is carrying a current I, and the area of this current is A, so finally magnetic dipole moment M is equal to Ia. Now, if the number of turns is n, so suppose this is one turn, two turn, three turns. The more the number of turns will be there, more dipole moment, magnetic dipole moment will be created. So let us suppose there is n is the number of turns. For n turns, magnetic dipole moment, n turns magnetic dipole moment m is equal to nia. Okay. SI unit of in this is ampere meter square a ampere, because current has a unit ampere and area has a unit meter square. So finally ampere meter square is the unit. Now if you want to if you want to define 1 ampere meter square, so how you will define? So 1 ampere meter is the magnetic moment of one turns loop of area of 1 square meter carrying a current of 1 meter. Let us consider it. There is a loop. This is your loop. It is carrying a current of 1 ampere, and the area of this is how much? 1 meter square. Area is equal to 1 meter square. Now the magnetic dipole moment will be equal to, and the number of turns is equal to 1 only. So magnetic dipole moment is equal to NIA we have studied, but N is your 1, current is your 1, area is 1. So finally, the amount of magnetic dipole moment is equal to 1 ampere meter square. So it is a magnetic moment for 1 turns of a loop of area of 1 square meter carrying a current of 1 ampere, and this is known as 1 ampere meter. Now let us discuss about the torque. Torque on a bark magnet in a magnetic field. Let us suppose this is the magnetic field and this is the magnetic field, and we have put another bar magnet in this magnetic field. So what type of torque will be created? So this magnet, this is the bar magnet having a length of 2L, and the magnetic dipole moment is in this direction. So M is in this direction, and this is angle theta, right? And the pole strength is small m, and this also a small m. So these are the two pole strength, right? So how many pole strengths are there? Two pole strength. This is M1, this is also M, and this is the magnetic field dipole. This is the magnetic field direction. Okay, and it is making an angle theta. Now let us suppose a force on the north pole. Now force on the north pole will be how much? Force, if it has a magnetic m and along a magnetic field direction b, so the force on the north pole will be mb. Force on the north pole will be mb along b. Now force on the south pole will be also mb in this direction. So there are two type of force which will act on this. So one will act like this and another will like this. So what will happen in the entire system? So total force will be zero. Why? Because one force is acting mb in this direction and another force is acting in this direction. So net force net force is equal to zero. So there is no translatory motion. If net force becomes zero, so no translatory motion will happen. Now let us suppose we know that couple and torque, when you apply equal amount of force in opposite direction, so what will create? It will create a torque, and which results in the rotational motion. Rotational motion, right? So we will discuss this thing, how this happens. Since force on the pole is along B and force on opposite along opposite to the B, net force is zero. So the torque acting on the bar is equal to torque. What is the formula for the torque? Torque is equal to force. So in equal amount of force into perpendicular distance between this line of action of force. So let us suppose here what is the line of action of force. So this is the first line of action of force, and this is also first line of action of force. Now if you take the perpendicular distance, so this will be the perpendicular distance, right? So this is N and this is A. So force, we have a magnitude of a force as mb and the perpendicular distance as a na. So if you want to find the perpendicular distance, this distance, so how you will find? So this is an angle theta. So as you know that this is a triangle, this is a right angle triangle, and this is angle theta, this is angle 2l. Now tell me, this is n and a. So what is the length between n and a? How you will find length and area? So we know that sine theta is equal to perpendicular by hypotenuse, that is equal to na by 2l. So in place of na, we can put here 2l sine theta. So finally we can put here mb into 2l sine theta. Now we know that 2l into m is equal to capital M into b into sine theta. So finally mb sine theta we are getting. So if you find, if m has this magnitude direction, b has this, b is also a vector. So if you find cross product, so that you will get as m cross b. So finally we will get the torque as equal to m cross b. M is the magnetic dipole moment of the bar magnet. Okay, so I hope you have understood this. So see here, we have already discussed torque is equal to m cross b. So you can write here from here also. The direction of torque is perpendicular to the plane containing m and b and is given by the right hand rule. So definitely m cross b. So let us suppose magnetic field is in this direction, and if your bar magnet is placed like this, so this is your south pole and this is your north pole. Let us draw it again once again. So let us consider my bar magnet is like this, and magnetic field direction is like this. So the magnetic dipole moment, direction of magnetic dipole moment will be from south to north. So what will happen if this is your m? So if you will find m cross b, so what you will get? So this is your m cross b. So m cross b. So finally m cross b will be mb sine theta. So the angle, the direction of torque will be in upward direction, that is perpendicular to this both. So this is your magnetic dipole moment m. This is your magnetic field. So direction of the torque will be upward direction. So use the concept of a cross product. Okay. Now note the tendency of torque on a dipole is try to align its m in the direction extended external magnetic field. Dipole in a non-uniform magnetic field. So in non-uniform magnetic field, what will happen? net force won't be zero because the product is mb, another product is mb, but not same amount. Why? Because magnetic field is not uniform, so this will be mb1, this will be mb2, so net force won't be zero. So what will happen? There may be the chance that this will move in this direction or either this direction, as well as it will also create a torque. So definitely it will also, torque may or may not be zero, so depends upon theta. So torque will be created and it will create a rotation, right? So finally we have got two type of motion in this. Okay, so I hope you have understood this. Thank you for joining the session. So if you have not understood, go through again and again. And otherwise, if you have any type of problem, you can ask me right now. Thank you.